Chapter 5.5, Bases Other Than E and Applications. Day 1, differentiate and integrate differentiate exponential functions that have bases other than E. We're going to start just kind of looking and seeing, okay, we can write all exponents in base E. And that's kind of how we do some of these problems as far as the differentiation integration to make them easier. A to the x, we can rewrite that as E to the natural log of A times x. Because really, the e and the natural log end up canceling out, and you end up having a to the x. All right? For logs, we can rewrite that. That's the change of base formula. Natural log of x, or log base a of x, we can write that as the natural log of x over the natural log of a, which really that's 1 over the natural log of a times the natural log of x. It's just change of base. This is really just a number, a constant. Okay? So as we look at this, let's find the derivatives for bases other than e. Now for derivatives, it's straight up, for a to the x, use log differentiation. Right? We'll take the natural log of both sides. Natural log of y equals natural log of a to the x. We can bring the x out. We got the natural log of y equals x natural log of a. Derivative of the natural log of y is y prime over y. Here it's derivative of x times a constant, which is really just the constant. So multiply both sides by y. Y prime equals the natural log of a times y, which is a to the x. So as you're doing this, you can see how when it was e to the x, it was just e to the x. Now it's a to the x. It's still got a to the x, but we're multiplying by the natural log of the base. If you did that with y equals e to the x, where it was e to the x times the natural log of the base, notice the base ends up being 1. So really what's happening is it's the same rule. But now because the base is different than e, you just got to multiply by a constant to convert it. And our constant is the natural log of whatever base you have. So if it was y equals triangle to the x, if triangle was a constant, y prime would be triangle to the x, but we would need to do an adjustment of natural log of triangle to get our derivative. For derivatives of logs that don't have a base of e, we use the change of base formula. Y equals natural log of x over natural log of a, or you can think of it as 1 over natural log of a times the natural log of x. Then we take the derivative there. All right? This is a constant. So we're going to use a constant multiple. We're just going to take whatever the derivative there is times 1 over a, or 1 over natural log of a. And the derivative of 1 over x, or derivative of natural log of x, is 1 over x. So you can see when we're taking a derivative of an exponent that doesn't have a base e, we're going to multiply by the natural log of the base to adjust for the fact that it's not e. When we're taking the derivative of a log that doesn't have a base of e, we're going to divide by the natural log of the base to account for the fact that it's not e. All right, so let's do some practice problems here. All right, here's basically what we went over. Derivative of a to the x is a to the x natural log of a. Derivative of log of x base a is 1 over x divided by natural log of a. Okay. It's the same as if the base was e, you just got to account for that change by multiplying or dividing by the natural log of your new base. All right, so find the derivative of each function. Y equals 2 to the x. Well, y prime will be 2 to the x. Because it's an exponent, we got to account for the new base, natural log of 2. All right, for b, y prime, well, it's 2 to the 3x, so it'll be 2 to to the 3x, it's got the 3x up there. It's got to multiply by the derivative of what's up there. And because the base is an e, we got to account for that too. So it'll be 2 to the 3x times 3 times natural log of 2. And finally, for c, log base 10 of cosine x, follow the log rules. Y prime, derivative of cosine is negative sine, over what's inside cosine. And then because the base is 10, we need natural log of 10 there on the bottom as well. It's the same. It's the same as natural log of x. It's the same as e to the x. You just need to remember to multiply to convert to a different base. It's a conversion. All right? Now here's where it gets tricky. And it's not tricky because it's hard. It's tricky because there's a lot of different rules you need to keep organized. All right? Now we got the power rule. All right? The power rule, that's a derivative from a long time ago. X squared, you take the power, put it out front, and power down. The derivative of x squared ends up being 2x to the 1. A lot of people will try to apply that to exponents because it's just something you've seen so much. You multiply the x out and power down. You get x e to the x minus 1. That's not the case because our power is variable. It's not a constant power in the original question. When the power is a variable, you need to apply exponent rules. When the power is a constant, you apply your power rule. All right? So here's some examples that illustrate the difference. All right? A. What is the derivative with respect to x of e to the x? Well, first off, where's our variable? There isn't no variable. It's e to the e, right? They're both constants. A constant to a constant is a constant. So what you want to do there is use your constant rule. What's the derivative of a constant? A constant never changes, so its derivative is 0. For letter B, where's our variable? Well, our variable is in the exponent, so we're going to apply the exponent rule. Derivative of e to the x, well, e to the x. And in letter C, where's our variable? Our variable is in the base. Our exponent is constant. It's a constant e, so when we apply the power rule, we're going to bring that e out front and power down. So the derivative of x to the e is e x to the e minus 1. All right? So in review, the derivative of a to the x. If y equals a to the x, the derivative of y, well, that'll also be a to the x, but because the base is not e, you're going to have to multiply by the natural log of our base. So the derivative of a to the x is a to the x, natural log of a.